All right, so for number 2, we have that point H. That means this guy here on a hot air balloon is sighted at the same time by 2 observers. Ooh, exciting. One observer is at the top of a vertical building that is 156 meters tall. Cool. So that is this guy here, point A. The other observer is at the base of the building, point B. All right, cool. The angle of elevation, what the hell is elevation? I'll talk about it in a moment. From point A at the top building to H is 40 degrees. All right, cool. The angle of elevation from point B to H is 57. Point X, this guy here, is directly below point H. That means I have 90 degrees here because it is, just directly above H. The information is already shown in the diagram. Thank you, IB, for being so kind to us. So, before we jump into part A, let's talk a little bit about what the heck is angle of elevation. So, in these trigonometry problems, I need you to know these two sort of buzzwords, buzz concepts, whatever. The first, of course, is angle of elevation that can show up in trigonometry, and angle of depression can show up in your teenage years as well. Anyways, I need you to have the intuition that angle of elevation is from the bottom to the top. And the angle of depression is from the top to the bottom. Now, for some of you, that is certainly not enough. See? And even for me right now, it's kind of like, what? What is that? See? So, let's say that I have 2 points. Okay, let's say that I have point X and point Y. Okay? If I draw a line between these two, okay, there are certain angles that show up, okay? Let's talk about angle of elevation first. I'm going to do it in red, okay? So elevation is going to be in red. So if angle of elevation is from the bottom to the top, you can think about it as an elevator. So you take an elevator to reach a higher floor, okay? And so basically, you would say, what is the angle of elevation from X to Y? That means you draw a flat line on X, okay? That technically goes like this as well, but you draw a flat line, all right? And you think, okay, how many degrees do I go up until I reach Y? So for example, you can have this angle here, which could be, I don't know, maybe 10, see? You have this angle here, which is, I don't know, like 5 more, etc. And you keep drawing these lines until you reach, until you reach Y, okay? And so once you reach Y, you are drawing this triangle here, which means it is this angle there. Kapow! That is the angle of elevation, okay? That is what they mean from the bottom to the top. You keep drawing lines until you reach Y, and whatever line reaches Y, you do your triangle, there is your angle, okay? Cool. Kapow. So this would be my elevation, okay? Angle of elevation. What happens with the angle of depression? So depression, we're going to do it in green. So the angle of depression is similar, just that it's like the other side of the coin. See, so again, since it's from the top to the bottom, okay? When you're depressed, you look at the floor a lot, dude. I don't know, whatever, okay? You draw this line up top horizontally, okay? And you ask yourself, from point Y, how many degrees do I need to do until I reach X? So I keep going, I keep going, I keep going until finally, kapow, I reach X. It goes like this. And this angle here would be, you said it, my angle of depression. Depression. Okay? So that is what they mean by angle of elevation and angle of depression. That is also how you get it. So in the context of this problem, when they tell you that, yo, from point A to point H, the angle of elevation is 40, you can see that they kept drawing lines, right, until reaching H. And once they reached H, they said, okay, what is that angle making a flat line on A? It was 40 degrees, okay? That is how they got the angle of elevation. And it's relevant to know that because for part C, they talk about angle of depression. So you might know what depression is, probably. You're probably a teenager watching this, so yeah, you know what depression is. But angle of depression, that might be new to you, okay? Anyways, whatever. Good to know. Shows up in trigonometry. There you go. Now we can start talking about the problem. So for part A, they ask us to find the size of angle AHB. So when they put it in that order, they're asking for angle H. See? Now the angle of angle, the angle of angle, angle H, which is next to A and B. See? So you're gonna look at AHB and say kapow, kapow, kapow. There's my A, there is my H, there's my B. What is the angle that is formed by those lines? This guy here. See? So that is the angle that we are trying to find. Okay? So basically, your compass, okay, like your north, what you should always be looking to do in these trigonometry problems, look at it. Trigonometry problems. See? Triangles. Focus on triangles. Think about triangles, how you can fill them in, what information you're missing, etc. And so if I look at this triangle here, the one that I'm going to put now in whatever, in yellow, see? This guy here, see? Try to find everything you can in regards to this triangle, see? And if there's information you're missing, okay, maybe you can get it from the triangle that's right next to it, okay? But you always gotta be thinking in terms of triangles, okay? What can you fill in, what can you not, etc. So, this triangle that I'm talking about, cierto, the one in green, the AHB, is next to a building, see? This building is a rectangle. And so if it's a rectangle, you have 90 degrees all around it. Kapow, 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 kapow. That means that right next to it, you have 90 degrees as well. Ah, interesting. So if I have a 90 degree right here, that means I have a 90 degree right there. Okay, that means this whole thing is also 90 degrees. All right, where are you going with that? Well, first of all, the case up here means that this whole angle, ¿cierto? Is going to be 40 plus 90. So that whole angle is actually 130. So that whole thing, ¿cierto? This whole thing is going to be 130. Okay? The whole thing. That whole thing is 130. And I'm actually going to cross out this 40 so that we don't get confused. Okay, that whole thing is 130. All right, what about down here? Well, down here, if this whole thing is 90 and this is 57, then this is the remainder. So I can say 90 minus 57 is going to equal quick maths, not so quick maths, 33. Yeah, so that means that over here, see, this guy in red is going to be 33. All right, and so now suddenly this exercise is much more feasible, it's much more approachable, etc. The sum of angles of a triangle is 180. So 180 is going to equal this 130 that I got in green plus this 33 that I got in red plus my favorite angle AHB, which is this guy here. See? So that means that 180 equals 163 plus AHB. That means that if I subtract 163 to both sides, I end up with AHB being equal to 17. So that is for part A. For part A, we found that the angle is 17 degrees. All right, for part B, we need to calculate the distance from point B to point H. So again, now I'm sort of like pulling out this triangle, see? So I'm pulling out this triangle that goes like this. This is for part B. I have the point B, the point A, the point H. I know that this angle we said was 130, if I'm not mistaken. Yes, this one right here is 33. And what I just got from part A, this is 17. See? What are they asking for? They're asking for the distance from point B to point H. So that is this guy going over to this guy, see? Which in the diagram, which is the same triangle, is this guy here. So this X, see? This whole guy, this X. All right, cool. How the hell can I find that? So in trigonometry, you have a couple of tools you can use, and actually, give you a moment, I can pull them out. Give me a second. Doop-de-doo. Analyzing, analyzing, analyzing. Kapow! Here's my formal booklet. See? The day of the AP exam, you were walking in with a couple of things. You're walking in with this guy. You're walking in with your brain. You're walking in with a pen and pencil, your graph and calculator, and everything you've learned, and the full confidence you have in yourself. So, trigonometry. See? Well, let's see. I have Geometry and Trigonometry, Topic 3, page 6 and 7. It's important to get familiar with it, to know the tools that you have, the tools that you don't have. And this is the big stuff for trigonometry. Okay, you have sine rule and cosine rule. Now, I have some videos that detail this a lot, but basically, I need you to think of sine rule as pairs. Okay? And for cosine rule, you're gonna use it if you don't have pairs. I'm not even kidding. That is probably the best way to do it. Okay? If you want to detail cosine rule a little more, it's kind of like missing one. Okay? If you're missing one angle or you're missing one side, you use cosine rule. All right? But yeah, whatever. See? Now, let's think about pairs first. See? Can I make Can I make pairs in this triangle? What I mean by pairs. If you see the formula over here, can I actually screenshot this maybe? I cannot paste it here. That is unfortunate. Anyways, for the sine rule, okay, so sine rule, I'm gonna do it here. So sine rule is little a divided by sine big A equals little b. This is divided by sine big B, and little c divided by sine big C. Now, as you see, you have two equal signs here. See? So technically, you can use whichever pair you want. Okay? So, whatever. I'm just going to use the two on the left. Okay? Now, what is little a? What is big A? What is little b? What is big B? Intuitively, it's the following. Let's say you have a triangle. Okay? If this is angle A, notice that it's a big A. If this is angle A, that means this is side little a. If this is angle B, that means this is side little b. If this is angle C, that means this is side little c. Okay? So, what's the intuition? Big letter, angle. Small letter, side. So, when we talk about pairs, we're talking about pairs of angles with sides. Okay, so this x, this side x, is paired with this 130. Okay, and so right now, if I apply the sine rule, I have x divided by 130 equals something else, cierto? For example, AH, see this AH here, and that would be the side 33. I mean the angle 33, see? So sine 130, sine 33 over here. So as you see, I have two variables. See, I have the variable x, the variable AH. And so what you need to do is find another pair. See, find more information so that you end up with a pair. See? Now I needed to do that whole blah blah so you guys understand why we're doing what we're doing, okay? If I were to just show you the answer, like, what the hell is that going to help you for the test, right? So we're going for pairs because sine rule works in pairs. And when I talk about pairs, I'm talking about an angle with a side. How do you know which is which? Big letter, angle, small letter, side. Draw this diagram, don't forget it. So let's go back here. Is there anything else I can get from here that can give me maybe a side of one of my triangles? Well, something that's cool about the IB is that usually, or at least what I've seen, is that all the information they give you is usually information that you end up using. And so let's look at the information that they have given us that we haven't used yet. For example, we haven't used yet this 57, we used it to get the 33. See? I don't think we've used yet the 90 degrees, and we haven't used yet that this building is 156 meters tall. All right, there's my hint. So, if you haven't seen it yet, I'm going to tell you. This 156 height of the building is the same 156 over here, which is actually the distance of A to B. So the distance of A to B is the same height as the building, which is 156. What units? Meters. So if I go down here, I actually have 156 as a side. Side AB is 156. Ah, so there's my other pair. See? So my first pair, I already put it. The second pair is going to be side 156 with sine 17. That means that if I want to get x alone, I cross multiply to both sides. I end up with x times sine 17 equals 156 times sine 130. That means that x equals 156 times sine 130 divided by sine 17. I trust the process. I put all of that into my trusty rusty calculator. If you want to do it quick in a fraction, you can press alpha y equals. Alpha y equals brings out this little tab. You press the first one. Boom, you have a fraction. It just looks kind of cool. You don't have to do it, but I think it looks cool. So, 156 times sine 130, close parentheses, don't fuck it up, divided by sine 17. Cool. How much is this? That. So, we have, with significant figures, 408.736. Let me actually put everything first. 736,314. See? Actually, just whatever. 736. Let's just leave it there. See? If you want to do three significant figures, you count 1, 2, 3, and this third one, you see if you round it up or down by comparing it to the one next to it. So if I have a 7 next to it, it's above 5, you round it up, you can leave it as 409. Don't forget your units, meters. So this x that I put before is actually, and I'm going to put it in a fancy color, is actually 409. Okay? Cool. That is for part B. Then they tell us that the hot air balloon remains at a constant height as it moves further away from the building. Describe in words the change in angle of depression, ooh, fancy words, from point H to point B. From this guy to this guy, ooh la la, as the horizontal distance between the balloon and the building increases. So, first things first, when they tell us it's a constant height, that means it is going to be the same height, okay? Same with an M. Apologies for my wonderful handwriting with a mouse. Same height is constant height, okay? That's also why in math, when they talk about a constant, so let's say you have, I don't know, like f of x equals 3x squared plus 2x plus 7, and they talk about constants. Your constants are 3, 2, and 7. What can change in this equation is the x. X can be pretty much anything here, okay? But your constants are in red. No matter if you plug in x equals 100, x equals 69, or x equals 420, you will always end up with the same constants, see? Your answer is going to change, yeah, because in one scenario, you're plugging in 100 squared, and in the other scenario, you're plugging in 69 squared, okay? Of course, this is going to be different, your final answer, but hey, your constant is the same. Ooh la la. Okay, that's constant. It never changes. Ah, okay. So the height of this guy is not gonna change. That means we're gonna move over, I don't know, over here, and my balloon is gonna be here, and the height is the same. The height is the same. So describe in words. Okay, we don't have to show anything. Describe in words how the angle of depression changes. See? And this actually goes back to what I showed in the beginning, see? So let's say I go further down the line. I go way over here, okay? How do you think my angle of depression is going to change in respect to x? If I go ahead and draw it, the angle of depression goes like this, ¿cierto? I count until I reach x. I end up with this, see? Which angle do you think is bigger? The green one or the orange one? Now, of course, visually, it's not like, I guess, so easy to notice it. So maybe use actually a little bit of imagination, see? Imagine here is someone you know, your friend, whatever, okay. And you are in a hot air balloon because why the fuck not? Okay, you're in a hot air balloon, see? Your friend is not moving, but the hot air balloon is, okay, at a constant height. Think about it. Think about the angle of your head. If you were very, very close to your friend in this hot air balloon, if you were very, very close to your friend in this hot air balloon, how would the angle of your head be? Dude, you would be looking like almost out of the balloon, straight down, pretty much, okay? So the angle of depression when you're very close is very big. But if you're very, 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 very far away, the angle of depression is much less. Ah, okay. So that makes a little more sense. Again, if you're very, very close to your friend, you have to look almost straight down. The angle of depression is very big. If you're farther away, your head isn't so tilted. See, you're looking more into the horizon, you're looking more horizontal. The angle of depression is smaller. So, what is the conclusion for part C? There's a lot of ways to put it, but how the answer key puts it, which I think is just fine, is that the angle of depression from the hot air balloon gets smaller as the horizontal distance increases. And again, I think the most intuitive way to understand it is think about extremes. See? Think about you being super close to your friend on the hot air balloon, being right on top of them. You are staring straight down. Now imagine that you're super far away. Well, you're not looking straight down. In fact, you're almost looking straight ahead, ¿cierto? It just has a little bit of an angle. So, ladies and gentlemen, that would be for number 2.